Okay, so welcome to my video on normal distribution. And throughout many problems in your textbook, you're going to see a set of numbers be described as normally distributed. And what this means is that the set of numbers is balanced. They're not heavily skewed to the left, they're not heavily skewed to the right. The set of numbers is normally distributed. And the reason why it's so important to describe a set of numbers as normally distributed is we could use this normal curve or this bell-shaped curve to describe the set of data anytime the numbers are normally distributed. And this curve is a very powerful tool that allows us to do things such as predict the chance of something happening. It also just gives us a better idea of what the data really looks like. So this bell-shaped curve is a very powerful tool that you're going to use throughout your course. So let's get started right away with an example, and this will make a lot more sense. Okay, so here in this problem it says that the test scores for a class are normally distributed. Okay, this needs to be given to us. They need to tell us that they're normally distributed, or you need to make a safe assumption that the data is in fact normally distributed. Okay, so now we know that it's normally distributed, so we can draw this normal curve. And it also says in this problem that the average test score for the class is 75. Okay, so I'm going to write that down with the Greek letter mu. This is the average. The average is equal to 75. And it also says that the standard deviation is equal to 10. The standard deviation for a population is written with the Greek letter sigma. So our standard deviation is equal to 10. And this problem is asking us to draw the data on the normal curve. Okay, and the first thing you're going to do is you're going to put the average, which is 75, directly in the middle of the curve. Okay, so we're going to go to the middle of the curve, and we're going to put our average of 75 directly in the middle. And this distance between one line and another line is equal to one standard deviation. So if we go to the right of the average, one standard deviation, we need to add one standard deviation, which is 10. So we need to add our standard deviation of 10. 75 plus 10 is equal to 85. So our value under this line is equal to 85. And so the same concept applies. If we go over one other line, this is also a distance of one standard deviation, so we need to add another 10. So 85 plus 10 is equal to 95. And the same concept applies if you go to the left of the average, but instead of adding one standard deviation, you need to subtract. So if we're going to the left of the average one standard deviation, we need to subtract 10 instead of adding 10. 75 minus 10 is equal to 65. And if we go over another standard deviation, we need to subtract another 10. 65 minus 10 is equal to 55. Okay, so now let's take a look at the area underneath the curve. The area underneath the curve actually gives us a lot of information. The area under the curve tells us the probability of a student's test score. Notice how half of the area is greater than the average of 75. So that means half is equal to 50%. That means that there's a 50% chance that a student's score is greater than 75. And also notice how half of the area under the curve is less than the average. So that means that there is a 50% chance, there's a 50% chance that the student's score is below 75. So this normal curve is a very powerful tool for predicting the probability of a student's test score. So now let's talk about the empirical rule. The empirical rule gives us the area in between one standard deviation and two standard deviations and three standard deviations. Okay, so what exactly is the empirical rule? The empirical rule states that 68% of the data falls within one standard deviation. Okay, so we know from the empirical rule that 68% of the data falls within one standard deviation above the average and one standard deviation below the average. And since this curve is perfectly symmetrical, we know that this area is exactly half of this area to the left. So if we take half of 68%, we know that this area to the right of the average and one standard deviation is 34%, and we know the area to the left of the average and one standard deviation is also 34%. 34% plus 34% gives us our 68%. We also know from the empirical rule that 95% of the data falls within 2 standard deviations. So we know that this area underneath the first standard deviation and the second standard deviation must equal 13.5%. This is because if we add 13.5% with 34%, with 34%, with another 13.5%, if we add all those together, that gives us 95%. So we know from the empirical rule that 95% of the data is between 2 standard deviations, or 95% of the area under the curve is between 2 standard deviations. Okay, so we've already described 95% of the curve, and there's only 5% left. So these two spaces are only 5% of the curve, and like I said before, this curve is perfectly symmetrical. So we can divide 5% in half to get each of the percent for these areas. So we know that one side is 2.5% and the other side is also 2.5%, which gives us the remaining 5% of the curve. Okay, so now we labeled the entire curve, and now I want to show you how you can use this curve and show you how powerful it is in predicting the probability of a student's score. Okay, you can use this curve to predict the score of all the students that scored below a 95. In order to do that, you just need to find the area below 95, and I'm coloring that in for you right now. Okay, so let's add all those areas together. The probability of a student scoring below 95 is equal to all of the areas below 95 on the curve. So we have 13.5%, we have 34%, we also have another 34%, I'll continue below. We also have another 13.5%, and we also have 2.5%. And if we add all of those areas together, we get the probability of a student scoring below 95 is equal to 97.5%. Okay, so now I hope you're getting a good idea of how powerful this curve really is. You can really predict any student's test score. So let's do it one more time. Let's find the probability that a student's test score is between 55 and 65. Okay, so the only thing that we need to do to find this probability is find the area between 55 and 65. The area between 55 and 65 is 13.5% of the total area of the curve. So we know the probability of a student scoring between 55 and 65 is also going to be 13.5%. Okay, so I hope this gave you a better idea of what normal distribution is, what the normal curve is, and what the empirical rule is. And my next video is going to be very similar to this one, but instead of using standard deviation, we're going to use z-scores, which are almost identical to standard deviation. So you shouldn't have any trouble in my next video. And I really hope that you're really enjoying these and that they're easy to follow. And I will see you in my next one.